Okay, let's keep going with this baby algebra. Let's see question 27 and 28. We want to evaluate the expression. So we're given this expression involves x, y, and z. And then we're given value of x, value of y, value of z. We just substitute this value into the expression. So 3, keep the negative sign. X is a 3 now. So 3 squared plus 2 times y. Y is a 2 now. Minus z. Z is 1 now. So this equals to, I still have a negative sign. 3 squared is 9. 2 times 2 is 4. Minus 1. So I still have minus 9, minus 1. That's minus 10. Right. I can add the negative numbers together. But negative 10 plus 4, I can think as negative of 10 minus 4. Right. So minus 4 still positive 4. Minus 10, I still have negative 10 plus 4. But mentally, I'm thinking, you know, I will get a negative number because the negative number is bigger. But then I do 10 minus 4, which is 6. So I get negative 6. Well, let's see this one. This one has an absolute value sign. Right? So we're going to do the same. Oh, this is exactly the same as above 27. We just have to do absolute value of negative 6, which is positive 6. Remember, what is absolute value? Absolute value means only consider the distance. The positive number, negative number, we call this real number 9. But negative 6, let's see, it's here. Absolute value means I only consider the distance of this number from the origin 0. Or the distance is 6. So we don't care about the sign, we just ignore the sign. Right. So let's do a couple more solve equations and inequalities. Let's see 29. Solve for x. So this equation, right? Because we have an equal sign here. We have an expression on the left-hand side. We have an expression on the right-hand side. And in the middle, they're connected by equal sign. So this is called an equation. So what do? We have 3x plus 5 equals to 2. Okay. You know, when I was young, I learned this way. I want to move this term to the right-hand side. Because my goal is to solve for x, 1x in the end. So I don't want plus 5 to be on this side. So I'm going to move to the other side. When I move from one side of the equation to the other side of the equation, the only thing I have to do is change its sign. Positive 5 this side, move to the other side becomes negative. So then this side I have 3x left. 2 minus 5, negative 3. Right? I know some of you are taught by, you know, subtract 5 on both sides is exactly the same principle. Now I have 3x equals a negative 3. I want to change 3x to be 1x. So how do I do that? I divide by 3, right? Because 3 divided by 3, that's 1. Then negative 3 divided by 3. Well, negative divided by positive, still negative. 3 divided by 3, that's 1. So x equals to negative 1. If we want to check, we put a negative 1 into x. So 3 times negative 1, that's negative 3. Negative 3 plus 5, indeed, 2. Now let's see 30. So we're going to do the same thing. But now we have 3x on the left-hand side. We want to move 3x on the right-hand side. We want to move 3x to the right-hand side, to the left-hand side. So when we move, positive becomes negative. At the same time, we want to move this positive 7 to the other side. Positive becomes negative. 5x minus 3x is 2x. 4 minus 7, that's negative 3. Divided by 2 on both sides. So we'll get a 1x equals to negative 3 over 2. You see, we don't bother to write a 1x, but if we want, that's perfectly fine. Just by convention, you know, people agree upon if it's 1x. So if it's 1x, we just write as x. If it's x raised by first power, we just read as x. If it's x divided by 1, we just write as x, just by default, okay? Those are convention. Now let's see 31. Inequalities. So this sign is read as less than. 2x plus 5 less than 3x minus 15. But when we solve, we do the exact same thing as the equation. Maybe we want to move 2x to the other side, right? So we have 3x minus 2x. Same time, we want to move negative 15 to the other side. Negative become positive. So 15 plus 5. We're keeping this sign, less than sign. 3x minus 2x, that's just x. 15 plus 5, that's 20. So this reads 20 less than x. Excuse me. So 20 less than x. But by convention again, we read from the variables. We would read as x greater than 20. Okay, so those two inequalities exactly the same. We read from 20, 20 less than x. Read from x, x greater than 20. So which means all the numbers, as long as it's greater than 20, can satisfy this inequality. So there are infinite many solutions, not like an equation. So 29, 30, we only have one solution. But for inequalities, we have an infinite number of solutions. 32, we're back to equation again. But here, we see we have parentheses. So we need to get rid of these parentheses. So how do we get rid of these parentheses? We can imagine this negative sign as -1. We distribute -1 to 2x. We distribute -1 to -4. So we keep writing x plus 3. -1 times 2x is -2x. -1 times -4, that's plus 4. This side, we want to get rid of parentheses again. We need to distribute 5. 5 is a common factor of x and -5. 5 times x, 5x. 5 times -5, -25. Now, on the left-hand side, we see x, we see -2x. We add those two up, that's -1x. Then we have 3 and 4 adds up, that's 7. That's 5x minus 25. Now we need to move around. Oops. Now, oops. Right click. I don't know, sorry, I lost my middle click. Doesn't show anymore, I don't know why. Oh, I lost it from here. -25, right? Now I want to combine the like terms on both sides, so I need to move around. If they're on the same side, I don't need to move around. I just combine them directly. But now they're on both sides, on different sides, so I need to move. So I have 5x plus x on the right-hand side now. I have 7 plus 25, because I had a -25 on the right-hand side. Now I move to the left-hand side, become positive. 7 plus 25, that's 32. 5x plus 1x is 6x. I divided by 6 on both sides. So I have 32 divided by 6. Well, both even numbers, I can divide by 2. So 32 divided by 2, I get 16. 6 divided by 2, I get 3. So our answer is 16 divided by 3. We can just keep it as this fraction, all right? Fraction is fine.